So we're gonna talk about proportional and non-proportional situations and how to tell the difference between the two. We're continuing our lessons. We're still looking at linear equations. We start out with proportional. What's the equation for a proportional relationship? Proportional relationship. What's the equation?
Y equals kx.
Y equals kx. Very good. So that's a proportional relationship because it goes to the origin. Now our other one is a non-proportional relationship, and what's the equation for that?
K equals Y over X.
Y equals mx plus b. So those are our two equations. And if you think about it, in a proportional relationship, b is literally 0 because it goes to the origin. It passes through the y-axis at 0, right? So let's look at these two. We want to determine whether each of these graphs represents a proportional or non-proportional relationship. Well, look at this one. Does it go through the origin?
No.
So is it proportional or non-proportional?
Non-proportional.
So it's non-proportional.
Is this all we do?
We're getting there.
Wait, hold on.
Yes, ma'am?
How do you tell? What do you mean if it goes through?
Does it go through 0, 0? Does it pass through the origin? The origin is where the x and the y-axis meet. Okay? Where your x and your y-axis. 0 is right there. Where I put my notes. Got it? So non-proportional, they don't go through the origin. Let's look at this. Well, what's the equation for this line? What will it look like? Will it be y equals kx or y equals mx plus b? Yeah, this one's going to be a y equals mx plus b. So that tells us it's non-proportional. These two mean the same thing. Let's look at this line. Does this line go through the origin?
Yes.
So what is it?
Proportional, really.
Proportional.
Well, I thought you said it had to go from both.
To be proportional, it just has to go through the origin.
Oh, okay.
That's it. There's no other fact about it. It's just got to go through the origin. Now, what's the equation for a proportional relationship?
K equals, no, Y equals K.
Y equals kx. Very good. So these two say the same thing. Proportional relationship, y equals kx. Yes, sir.
I've been thinking about this. Why isn't M the K? Why don't they...
Because somewhere in the past, one mathematician wrote one equation, one wrote the other, and it's just like any other invention. It gets stuck with what it has. Why don't we use A, B, C as our variables?
Yeah.
Because the Pythagorean theorem uses A, B, and C as the sides of a triangle. And that theorem is older than most of them.
It's square.
So, because it's already there, it's left alone. If Tom Wheeler was mathematician supreme, I would say let's ditch the K and just call it slope like it is. But they don't. They represent the same thing. Okay, let's look down at some equations. Or after this phone call. Good morning. Yes, ma'am. Hooray, go see Miss Martin. All right, so let's look at these relationships, and we've got just the equation. We want to know whether it's proportional or non-proportional. Well, what's the equation for a proportional relationship?
Y equals KX.
Y equals kx. So we're looking for something that looks like that, where we've got a variable and a variable with a number there. How about a non-proportional relationship? What's the equation? Somebody across the room there.
What?
What's the equation for a non-proportional relationship?
Y equals mx+b.
Y equals mx plus b. So we're looking for something where we have a variable with a number in front of the first one and nothing in front of the second one. So let's look at this first equation. It's not written as y equals mx plus b, is it? It's got d and t. What does it look most like?
Y equals Kx.
So what is it?
Proportional.
It's proportional. All right? That one made sense? Look at this second equation. P equals 0.1s plus 2,000.
Non-proportional.
Why do you say that?
Because it
Decimal?
equals mx plus y equals mx.
Yeah, they just, instead of y and x, they're using p and s. But they're in the same spaces, aren't they?
And then the
So that's non-proportional. Who said, wait, what?
Landon. It's because it has that plus sign.
Yeah,
If it didn't have
It
the
looks
plus
like
sign,
an
it'd be
equation.
that's not true either. The plus sign really doesn't affect it because it could be a negative 2,000, couldn't it?
well, I mean,
So
but
wait,
if it
then how
doesn't,
do we know?
Well, Landon, look at this. P equals 0.1s plus 2,000. Does that look the same equation except they've replaced y with p and x with s, right?
Oh, okay, yeah.
They've just used another variable name.
Wait, but where's M?
M is the number right in front of the...
it's the point.
So
Look.
the plus sign doesn't matter?
Nope. Look at this. There's your m. It's right in front of your second variable, isn't it?
So x
And
is
there,
this.
there's your initial value, your constant.
Oh, so it's Y, M, X.
Yes, sir. And if that helps you, write y equals mx plus b. If that makes you happier, Landon, that is a perfect example of doing good stuff.
Okay.
Let's look at this next one. It looks a little funkier, and I got a lot of other conversations. Let's look at this next one. It says n equals 450 minus 3p.
Proportional.
Non-proportional.
What did they do?
They switched the B and the MX.
They squished the mx and the b. Does it really change anything?
No.
No, they just went y equals b, like, plus mx, right?
And minus MX.
So this is still non-proportional. They just wrote it wrong.
But there's a minus sign.
Can you have a negative number?
Yes.
Yes.
Landon, all that the minus and the plus don't mean anything. That just tells us whether it's a positive or a negative number involved.
Okay.
Let's look at this other one. Y equals x3.
That's proportional.
Why?
Because it doesn't have
Because
the
it doesn't
equation.
have
Did they write it correctly?
no.
They just switched the m and the x, right? They were on backwards. But it's still proportional.
That's just like fiction and non-fiction.
This is easy.
Now, let's talk about a couple of situations you're going to run across where it's going to look odd, where you get something like y equals x squared. If you get a variable and there's a square in it, it's not a straight line. It's actually a curved line. So it, by nature, it's non-linear. If it's non-linear, it can't be proportional or non-proportional. It's just not a line.
Well, so if that happens, we just put non-linear.
If you get something where they take and they put it inside a radical sign, it's also non-linear. It's going to make a curved line. So if you get either one of those, they can't be proportional, they can't be rational because they're non-linear. If they're not a line, they can't be a linear equation. Does that make sense? You will run across those in algebra, and you'll start seeing it as more of a trick than anything else here. So if you see y equals x squared or y equals 2x squared plus 6 or something like that, if that variable is squared or cubed or whatever they want, if it's to a power, it's not a linear equation. If it's a, yeah, it is a trap. If it's a radical sign, it's not a linear equation. All right, so let's look at these down here. We're going to decide if they're linear equations. Now, I could type these into the calculator and find and see if that works. The calculator will try and make it work no matter what. I could do a bunch of things, but here's the easiest thing I know to do. We're going to find the difference in y over the difference in x. So we're going to find the difference in y over the difference in x. If the difference in y over the difference in x is not the same everywhere, then it's not a line. So let's look here. What's the difference between 2 and 8?
6.
6. It adds 6. How about 8 and 14?
6.
It adds 6. 30 and 90.
30.
That's sad.
60.
60. How about
60.
60? All right. So the difference in y, which is 60 over 6, does it stay the same each time?
Yes.
So it is a line. Let's find out by regression if it goes back. So I'm going to put the difference in y, which is 60, over the difference in x, which is, what does 60 divided by 6 equal?
10.
10. So what this is saying here is my slope is 10.
So it's not proportional.
No, we're good. But let's go backwards in time. So if I need to go take 2 to 0, what would that be? From 2 to 0,
2.
it would be 2. Now going this way, since this is basically 1 times 10. Do you agree?
Yes.
So 2 times 10 is what?
20.
20. So subtract 20 from 30, what do we get?
10.
Is this going through the origin? If x is 0, remember, when x is 0, y is b. Does that go through the origin?
Yes.
Does it go through the origin?
Yes.
Is the coordinate 0, 0?
It doesn't go to the origin.
It doesn't go through the origin, which means it is a line,
But it's non.
but it's non-proportional.
Nice try.
Wait, what? Non-proportional?
Yes.
Because it doesn't go through the line.
Because it doesn't go through the origin.
Origin.
Another close one.
Okay?
But it's 0.
I'm getting
Oh,
it.
it's 0, 10.
X is 0, but y is 10, which means our b is 10, which means it doesn't go through the origin. What equation does it use?
Y equals
Y equals
mx plus b.
Y equals mx plus b.
What?
Let's look over here. What's the difference in 5 and 40?
5.
35.
Guys, slow down. What's the difference in 40 and 65?
35.
Really?
25.
25. What's the difference between 1 and 8?
7.
How about 8 and 13?
5.
5.
Okay, so now I'm going to put y over x, 7 over 35, and I've got another one because it's different, 5 over 25. So what's 7 over 35 simplified?
5.
No, not 5.
Oh, simplified?
1/5. What's 5 over 25?
1/5.
So we know it's linear because all the ratios came the same, right? Everyone agree?
Yes.
Yep.
So let's regress back because we know now we've got 1 over 5. That's our ratio, right? 1 to 5. So let's go back till x is 0. How many did I move?
5.
5.
So if I move 5 here, 1 to 5, well, that's easy. How far do I have to move here?
1.
1. And that puts me at?
0.
So do I have 0, 0?
Yes.
So what kind of line is it?
Proportional.
Wait.
Proportional. What am I waiting for?
He's gonna try something.
And what's the equation for a proportional line?
Y equals kx.
Y equals kx.
Good job on that.
So all you're doing today is deciding, is it proportional or is it non-proportional? If it goes through the origin,
It's not.
it's non-proportional. Somebody tell me how I could also find these using a calculator.
Oh, you
Go to
type
graph.
all of it in the little graph.
I could type all into the spreadsheet and see, because this one will end up as b is 10, right?
Yes.
And slope is 10.
Yes.
Not in the middle of the lecture. Go sit down.
Ow.
This one, when it came in, it would tell me that b is 0. The y-intercept goes through 0. And m is 1/5. You see that?
Yes.
Or it would say 0.2, because that's 1/5. Does that make sense? So you can use your calculator. You can use regression too. Regression is functional. It takes a little bit to use. Once you get really good at it, it gets really obvious. You start seeing patterns and how they stack. Are there any questions? Landon?
No.
You got this? Kind of a little hard on your mind there today? It's the Chick-fil-A that you had that did you under, man.
It was a pickles.
Probably it was the pickles. All right, stop your recording.